Welcome to Geometric Virtual Learning, and a warm welcome to new viewers as well. In this lesson, we'll be talking about proving congruence of shapes and how to use cross-facts from other topics to help prove congruence of shapes. So may I suggest, if you haven't watched lesson 1 on congruence, you go back to watch that, because in lesson 1, I discussed the 4 main postulates that we could use in proving congruence of shapes. So if you haven't, please go back to lesson 1 before you watch lesson 2. Thank you. Example 1 is congruence involving properties of shapes. So ABCD is a parallelogram, and ABP and QDC are straight lines. Angle ADP equal angle CBQ 90 degrees. Prove that triangle ADP is congruent to triangle CBQ. Such questions, as you read, you check the information. If it is not there, you make sure you put the information there. So, for example, 90 degrees is there for us. Now, questions like this, it's best to highlight the two triangles, possibly with different colors, so you will really be able to know the markings. So I have red right angle triangle and a green right angle triangle. So let's start the proofs. How do we prove that? First is AD is equal to BC. How do I know that? Because opposite sides of parallelogram are equal. Second, angle ADP and angle CBQ are all equal to 90 degrees, and is given in the question. Also, angle DAP, and BCQ are also equal, because opposite angles of a parallelogram are also equal. So I'm just using properties of shapes to help me prove the congruence of the shapes. Now, once you've done that, sometimes it's very difficult to see the true postulates to quote. So it's best that in an exam, you draw the triangles separately, so you could really see your markings well. So let's separate the triangles. Now it's clear here, we have angle, side, angle, angle, side, angle. So we can say that triangle ADP is congruent to triangle CBQ by condition ASA. Obviously, this is not the only way you can prove it, but you can use this postulate to prove it, that these two are congruent. Somebody might try to use right hand side. They all will work depending on how you quote it. So I've proven it using angle, side, angle. And of course, the marking scheme will accommodate a variety of proofs. Example 2. We have congruence of shapes question involving circle theorem. So here you need to remember your circle theorem rules to help you really prove that the two triangles are congruent. So AEC and DEB are straight lines. So as you can see, AEC, DEB. Triangle AED, AED is equilateral triangle. So that is equilateral triangle. Prove that ABC is congruent to DBC. Right. Now, important information we have here is that AED is equilateral triangle. It will help us to really help us with our proofs. So let's see. We do the mark. Let's mark the triangles. Highlight the triangles first. We know that given that this equilateral triangle, 60 degrees for each of the angles. Having known these angles 60 degrees each, we can now begin by saying that this angle here, 60, is equal to this angle. Alternate angles in the same segment are equal. These are circle theorem that, if you've done the topic, you should remember. So angles in the same segment are equal. Also, this is also equal to, because they are also angle in the same segment. Given this as a chord, these angles in the same segment must be equal. We know that if that's 60, this is also 60. And this is 60, 60 as well, makes this also equal to a triangle. That means that this line here is equal to this line here, and it's equal to this line here. So we have another equilateral triangle. It's going to help us with our proof, so just hang on a bit. Then we also know these two angles are equal, though we don't know the value yet or the size yet, but they are also equal. Reason is the same segment angles are equal. Now with these markings that I've done, if you sort of pull the triangles apart, or if you drew your triangles apart and do the markings, you will see something. So you could see this angle is equal to this angle because they have the same marking. They have a common line here, and 60 degrees is also equal to this 60 degrees. So we can say the two triangles are congruent by the condition angle, side, angle. That's how I would like to prove this question using circle theorem. So angle, side, angle is the postulate that I'm using to prove that these two triangles are congruent. Next, we have AOC and BOD are diameters, as you can see, and O is the center. We need to prove that ABD and DC are congruent. Okay, so let's mark them. We start, they have a common side, so AD is common. AOC and BOD are the diameters, so we mark them, and the diameters are equal. And we also remember that triangle in a semicircle is right angled, and because this is the diameter, this corner is 90 degrees, and that is also circle theorem that if you've done it, you should remember. So you can see from this that this could be proven using right angled, hypotenuse, and a side, because we have what? A right angle, we have a hypotenuse, and a side. So this is proven using right angled, hypotenuse, and a side. Right angled, hypotenuse, and a side. Example 4. ADE is right angle. ABCD and AEFG are squares. So these are the squares on a right angle triangle. We are supposed to prove that ABE, and ADE are congruent. Okay, let's mark them distinctively. So this is what we have. First, we know these two are equal because they are the same side of the same square. So they must be equal. Also, these two are equal. These are also equal because they are also the same side of another square. Now, what we need to understand is that a square, each angle is 90, so these two angles are 90 degrees because it's given to us that it's a square. One thing we need to remember that there is a common angle which is marked with a black arc, and you could see that in angle EAB is the black angle plus 90 degrees. Also in angle DAG, you could see it's also the black angle plus 90 degrees. So that means that they all have a common angle plus 90 degrees. So that means that we have a side angle side, a side angle side. The same here, a side angle side. So the triangles ABE and DAG are congruent by the condition side angle side. Now try and see if you can use the same condition in previous slide to prove that triangles FDE and AGE are congruent. It's similar to the first one. We have right angle triangle and we have equilateral triangle of different size on the sides of the right angle triangle. When we're ready to check, press play. Okay, let's check. So we mark with different colors to help us identify the markings. We can say these two are equal because they are the same size of the same equilateral triangle. Also, these two are the same because they are also the same side of another equilateral triangle. We know these are 60, 60, 60 because angles in the equilateral triangle each equals 60. So we know that. But in this angle, we have a common angle plus 60. In the yellow one too, we have a common angle and it's 60. So that tells you that AEF, angle AEG, and angle DEF, as you can see, AEG is equal to a common angle plus 60, and DEF is also equals to a common angle plus 60. So that makes this angle equal to that angle. This angle is equal to that angle. And if that is so, we can say the two triangles are congruent by the postulate side, angle, side. Side, angle, side. And that brings us to the end of lesson 2 on congruent shapes. Hope you've enjoyed it. Please share with your friends and make sure you make notes whilst you watch these lessons. Thank you very much for watching.